going to begin answering some of these questions here in the chat section. And after I go through the chat section questions, I see a few people have put up their hand to speak. We'll give that a shot right afterwards. So the first question was, how do we decide on the shanty parameters? The shanty parameters were really a mixture of you need to have the correct, you need to have good quality ground. If the ground is so poor that it unravels, it may not lend itself naturally to be shantied. So caution has to be placed on making sure the ground is good, working with your geotechnical engineers and seeing what actually happens in the field. The dip shown on the hanging wall in the pictures was set at 55, and that's more of a pragmatic function. You have to be able to fit equipment in there. If it goes much shallower, for a couple of reasons, you can't really ground support that. It becomes really awkward and difficult. So 55 is probably your lowest practical angle, but it can be steeper if required, all the way to vertical as if required. So that was probably the key ways and parts of that for figuring out the shanty. The next question was, one of the challenges in narrow vein mining is grade control, especially in areas where low density drilling. Can you recommend a practical solution on how this issue so that the variance in tons and grades between plan and real could be minimized? Okay, so what did I have here? A couple of key things were mentioned were geology control. So as you're mining, you're going to be seeing the best diamond drill hole that you can have, infill drilling hole, really is the drift itself. And if you're mining on geology control, you're going to see the full face, especially if it's visible ore, and or taking samples from the face and properly mapping that. And what you have to do is live update your working block model. A resource block or a reserve block model will end up being, it's a little bit less information. I also talked about the infill drilling. So that together with the geology control, the actual face mapping in the underground, you have to provide your frontline engineer as well as your geology department with a live working block models, and you have to keep it updated. It requires a significant amount of work keeping up with the pace that a mine actually moves at, but it is key to reducing the amount of, to improving your grade control and to help you with reducing dilution. I think that was the two key points that I was thinking about for that. There was a question, is it a good choice to blast the ore and waste parts separately, basically resuing, when you push the development drive to control the dilution? Or can it be blasted one round and then we're using blast technology to cast the waste far away from broken ore? There have been people who have attempted to do it all in one blast, but it doesn't really work out quite so well. It doesn't separate the muck piles. So resuing would be the way to do that. Either you blast the ore out first and muck that, and then do a separate blast for the waste material. As part of this study, there was no resuing. The operation already was doing resuing with handheld equipment, and the intention was to move away from using handheld equipment in as much as possible for health and safety purposes, and they didn't want to necessarily continue on with that method if possible. But yes, if you can separate the blast, that would be great. I haven't seen personally as much success trying to cast the waste material separate so that you can muck it independently of the ore. In particular with narrow vein mining, you have such a confined little space, it unfortunately doesn't naturally lend itself to allow you to do that. The next question was from Vivek. How was ANFO charging mechanized? Yeah, this is a good question. Unfortunately, I don't, it would still be using an ANFO pot. I haven't seen a mechanized piece of equipment small enough to fit into a small drift, as we were mentioning, the 2.7 by 3. When you get a little bit bigger drift in the 4x4 range, I know a variety of different manufacturers that provide ANFO or emulsion chargers where they can fit into the section profile of the drift for either cut and fill or for long hole. But otherwise, yeah, that was not mechanized for particular when you get into the small drifts. I'd say under 4 meters by 4 meters, but you'd have to really look at the size of your piece of equipment specifically if you were to use the mechanized ANFO piece of equipment, that, you know, a rubber tired vehicle that can go into a drift. But as far as this study was done, it was still going in there with an ANFO charge, like an ANFO pot, or even an emulsion loader is another way, where they have the small units. All the explosive supply companies have different pieces of equipment that could fit into small sections, such as these, where you put it out in your central access drift, and you could run the loading hose all the way down the drift, or even bring the actual charger into the drift itself. That would be true for ANFO as well. Okay, I hope I answered that. Thanks. Okay. Oh, Vivek's saying that they might be able to help. Maybe I'll chat with you after about that. The next question was from John Barber, and it says, do you have a feel for the maximum long hole open stopes height for narrow stopes from 2 to 3 meters in width? Usually from 20 to 25 meters. Once you get much over 25 meters, and in particular when you're really narrow, you're using a smaller diameter drill hole, and that the drill steel and the bit become less stable with distance, it becomes more challenging to maintain a proper straight hole. And as I've mentioned before, in the earlier, was that the accuracy is the most key important part of effectively breaking your rock. And if your holes start to wander too much, it may not provide you with the level of accuracy. So you will start to see increases in dilution if you start going much higher. So I would say that's probably in the neighborhood of what the maximum would be. Okay, a couple more questions. We see that the stope strike length exceeds 20 meters, causing excessive dilution. So reducing stope strike helps in my experience. I'm guessing that's the comment from Anton was with regards to the strike length. When he says when the stope length exceeds 20 meters, he starts to experience excessive dilution. I'm guessing that may be something to do with either the hanging wall unraveling, but I'm not sure how to answer that question right now. A couple of questions about, will a copy of the presentation be available? Yes, the presentation will be available afterwards. It'll come to you within 24 or 48 hours after we look at it and fix it up if there's any problems. So yes, you will be receiving it. Yes, presentation. You mentioned 0.3, another question from Valerie here. It says the powder factors from 0.35 to 0.75 for long hole open stoping. What rock mass properties does the rule of thumb follow? Generally, most ore generally follows the same powder factor. Depending on the density of the ore, you're going to have to increase your powder factor. If you have, let's say, a lead zinc mine versus a copper porphyry type of deposit, which would be less heavy, well, lead zinc being a heavier, denser ore would require more explosive powder, so you're going to have to adjust your drill hole parameters, basically going to a larger drill hole size, and then hence you'd have to open up your pattern. So, or you'd have to tighten your pattern on your drilling such that you'd be able to get more drill holes so that you'd be properly distributing the explosive energy within the zone that you want to blast. So it generally works for all different types. There is a certain amount of jointing and natural features that exist in rock masses that necessarily easily controllable, but the ones that you can control are your drill and blast design patterns, and using the proper equipment and taking time to make sure that it's drilled as accurately as possible. All right. Another question from Pavel Kuzmin is, what software do you use for mine design stopes? The one that I'm most familiar with is iRing. It's also been sold through other distributors by like Vulcan, Deswick, or not, maybe not Deswick, but Datamine. It's called Aegis, Aegis. It's an excellent software. It does predictive breakage amounts. Basically, you have the drill hole, and then it'll create a cylinder around it by which it'll try to approximate the amount of breakage you're going to experience. Also, there's the old-fashioned, old-school way is you use known calculations for your burdens and spacings, and you manually draw it with any CAD-type software, any one of them. Providing you look at your parameters, your powder factors, there's rules of thumbs for long hole open stoping for your toe spacing, and you want to make sure your collars and loading of your holes don't come too close proximity such that you're going to have too much energy in one spot, which could cause other issues like dead pressing or desensitization of adjacent blast holes that haven't initiated yet. So yes, so I would say iRing or Aegis, and they are available from all the big manufacturers. Old mine companies are trying to mine the wedge left previously. How should the dilution be reduced there? Mohammed Tarek was asking a question. As old mines companies are trying to mine the wedge left previously, how should the dilution be reduced there? I think I'd have to probably see specifically how that was being applied, and I could probably better answer that if I actually had a physical illustration. So I'm sorry, Mohammed, I don't think I could directly answer that question. From Philippe Lebleu, you have talked about reducing dilution and benefits. Do you need to trade off against increased costs to decide what is the best method to use? Yes, there definitely, that could be something to be further studied. In this case study, the strong mandate really was on reducing dilution because of the high quality of the ore. But it's true, when you reduce your drift size and the amount of drilling and effort that goes into it, the labor, you are going to increase your costs. There's no question about it. But like I said, this case study really didn't go into the guts of that. And yes, it would be an opportunity where we could work with you together to try to look at the costs that are associated with it. So yes, every mining method has different costs and different overall expenses. So it would have to be looked at in detail. Okay, Brian has a question about, I hope I answered that well. Brian is asking a question. You mentioned the powder factor was 0.3 to 0.75. Was that for the most narrow stopes? And those numbers were calculated on? Yes, so for the narrower the stope, the more highly confined it is, and the more powder you're going to have to use. So the powder factor, when you get into the very narrow stopes, you'd be increasing your powder factors. If you have an existing operation, you have probably a strong indication of what your powder factors are and how everything is breaking. And from there, you can make adjustments by changing your patterns. You know, you could buy different bits and different steel, relatively straightforward way by which you could switch over to a complete design, you know, on your very next stope almost immediately. So, and those powder factors I'm mentioning is after you've established your slot in long hole open stope, meaning you've put in your raise, you've blasted it, and now you have an open free face. The powder factor in your slot is always much higher. You have a large density of drill holes, and you're trying to pulverize and crush and eject all that rock in the close proximity to the slot raise. So once you've established your slot, those powder factors are the numbers I'm talking about. It's just the rings after your slot is open. So was the most narrow stopes? What was the most narrow stopes that those stopes. Oh, okay. Sorry, I misunderstood the question. So yes, the most narrow stopes were in the width of about, we've seen some clients in old case studies that said they were getting to as low as 1 meter. Some people were getting under a meter. We have some photos. I think that's a challenging target to shoot for, but it would definitely be the lower limit. I imagine the stope panel would have dropped down to about a meter, sorry, 15 meters in height, where you're only actually drilling about maybe a 12 to 13 meter panel, such that you'd be getting really accurate drill holes that would be exactly as per layout, using proper survey control to make sure everything was exact. Okay, we have a question. You suggest 57 to 76. I have suggested if you have squeezing problems with our holes. Yes, squeezing in situ stresses in the ground, definitely lots of re-drilling and challenging. And the smaller the hole, the more challenges you're going to have with them plugging up with debris if the holes are squeezing. Also with ANFO, when you start hitting a lower critical limit down to the 57, you're getting to that marginal limit where you're going to really struggle to actually the critical diameter where it doesn't maintain the velocity of detonation. So you always have to have boosters in every single long hole open stope to get your velocity of detonation, which is basically how much energy the explosive it has. So you have to keep your velocity up. And if you start getting into the small range, yeah, it becomes challenging. I'd almost suggest switching over to an emulsion-based product when you get into the smaller sizes. It has much more energy than you would experience with an ANFO, and that'll help you keep the hole fully coupled with the explosive such that you're going to get that energy maintaining. And like I say, periodically placing boosters. Another thing that is key is to always include, for narrow veins, I always double cap every single blast hole or more, because if you have any form of cutoff, the hole's in close proximity. If the ground shifts, you have a second cap. Like at the toe of the hole, you'll have a cap, and then midway up the column, you'll have another booster that has a cap in it, such that it's a primer. So double priming every hole is another key thing. It doesn't cost very much to add a second primer. Probably $10 Canadian, I think, is roughly for a cap or less. And then I'm not sure what the price is, but yeah, double priming, switching to emulsion, and squeezing with small diameter holes. Yes, it presents a big issue and a problem. So maybe through the series of changing to emulsion, as well as more effort placed on redrilling, which unfortunately is time consuming, but it is required, Lewis. How about opening a slop with regular blasting in long hole? Would you use something similar to an opening and development, or use some other equipment that is not available? What powder factors we use in comparison to a regular production hole? Yes, a conventional, instead of like a large diameter V30 that we showed in this particular case study, yes, you could use a conventional raise. And what I mean by that, yes, it would look much like the parallel slot holes for the development rounds, but now you're creating and establishing a slot in the long hole panel itself. You have a series of unloaded holes and loaded holes. They work just fine. Although a bigger relief hole is an improvement. If you're doing a conventional raise, you already will have your existing long hole drill, and you start with your pilot hole, and then you ream it out to the size that you need. And yes, there are small long hole drills that are either pneumatic, which are powerful to do enough to do everything that I've talked about today, or you can even get the hydraulic versions of these small type of drills. There's several manufacturers that make them. And yes, it's conventional equipment. It would be nothing specialized other than maybe buying a reamer bits to match the amount of relief hole required. And what kind of powder factors would you have in comparison to a regular production holes? I'd have to go re-examine that, but I think it's in the neighborhood of between 2 to 3 kilograms per ton in the raise. It's really high. It seems counterintuitive, but it's not. It is like that. Likewise with the burn cut if I switch now to development, the burn cut has a high density of loaded holes. So yes, you do have really high powder factors in your cut, in the burn cut, and likewise with your slot. It took me a couple of years to finally realize that how come these powder factors are so slow when you include the slot in the overall stope powder factor. And it became apparent with some experience in years that those numbers that people are talking about most often in the guide handbooks that you see are talking about the production rings. So yes, the slot is going to have a much higher number. I'd have to do an actual calculation to refresh my memory, but yes, it is much higher. Okay. Still sort of mixing after casting blast. Okay. In Avoca mining, this is Ian Looney asking a question. In Avoca mining, the barrier between previously blasted long hole block waste fill and freshly blasted ore often blends, introducing external dilution. What strategies, other than consistent CMSs after each blast, can help with external dilution? Yes, for Avoca mining, if you are able to maintain a far enough distance where you don't have to backfill in behind it and you can leave an open panel, it allows for an opportunity for the ore to fall to the ground and minimizes the amount of fill you're intaking. Other situations, it's just the hanging wall and the ground isn't good enough or strong enough that it starts to slough. So you have to actually fill the panel full, muck a little bit with waste, and then you have to go muck out some of the waste. Or you can just leave it full and then try to blast it directly against it, and it creates a packing type effect onto the Avoca fill as you reestablish your slot. It is a challenge to maintain and minimize the amount of dilution. Another way that I've seen this where we started to see excessive dilution was to take some grab samples out of the bucket. You might take a handful of ore. When you know that you're in the ore, you're in the ore. If it's visual, you could see it changing color. It's where geology would come into play very much so. And you would have your operator take 5-10 buckets and take grab samples out of the bucket, and you send it to the lab. Hopefully on your night shift with your quality control group, they can do an assay on your ore, and you can make a decision on to continue mucking or to, from that point forward, call it too much waste. It's too diluted, and hence you would stop mucking it as ore, and you'd switch over to either backfilling it for the Avoca, or you would take another blast, which would be more ore, such that you wouldn't be below your cutoff and mining too much waste. I hope I answered that well. Yes, you're correct. Just stated. Do you have experience in long hole where the slot is drilled in every stope, but poly pipes are placed in the backfill stope to act as the next free breaking face for the neighboring stope? Yeah, there's a variety of different things that I've seen before. I've seen sections of pipe. I've never seen poly pipe, but I've seen foam blocks. I've seen round metal pipes placed into the adjacent stope that would help with this. Yes, so you don't have to reestablish your slot each time. Yes, there is a high amount of drilling, blasting, and effort that goes into establishing your slot. So if you can use a poly pipe into the backfilled stope, yes, it does work well. I haven't used it yet myself, but I have seen and read a number of articles and distributors who are selling products where they can provide this. So if you reach out, we can try to look at trying to find and source something that might work for you locally where you're situated. That was Anton asking this question. How can we control dilution in non-mechanized narrow vein mining? This is from Majda Wab. For non-mechanized, this case study didn't get into it, but I think you're suggesting handheld equipment where it's not mechanized. That's what I'm reading. And yes, there is. I've seen a a variety of different ways to do this. You can do resewing where you're drilling horizontally and you blast the ore, muck it, blast the waste, muck it. I also seen where um, the jumbo goes in and does backslash holes, the same concept where you slash out the ore, muck it out, spot, bolt, and check, because now you have broken ground above you, above your head. So you have to ensure the safety. And then you do a secondary blast, which is taking out the waste. Now the waste ends up sitting on the floor, or wait a second now. No, yeah, you have to muck out the waste, and eventually you bring it back in to build up your floor to the next cut. So that is a common way to do that. As for dilution control, yeah, it'd still be back to all of the key parameters we had mentioned before. Your powder factors have to be right. You have to choose the appropriate drill hole sizes. If you're doing lateral development, if it's a cut and fill, yes, perimeter control will help. For on the one side, you could do half the perimeter blasting on the control on half the blast, and then do the similar on the opposite side. Again, it is extra work, but it would help you maintain the integrity of your surrounding country rock, which is your waste material, which you don't want to mine. So some of the practices are the same. It's just that you're going from a mechanized to more of a manual mining method or handheld equipment method. What is your opinion about the Swedish Loader and tracing your products with det cord well loading? The Swedish Loader, from what I've had experience, it's always been used for the long hole open stoping, where you're doing blind up holes, was where I've seen it used, but you can use it for down hole. And it's it works well, absolutely. It is a little bit of a more manual process than using an ANFO pot or an emulsion pumping machine, but it can be used. The thing about it is, now if you're moving towards packaged explosive products, your costs are going to go up. The unit cost for each a bag of product, packaged product that you insert with the Swedish Loader is much more expensive. It's 3 to 5 times higher than if you're using a bulk product such as an ANFO or an emulsion. So for cost reasons, I prefer bulk all the time, but there are certain circumstances where I've seen people keep an inventory of packaged product due to really fractured and broken ground, but still trying to maintain the use of bulk products because the cost is just immensely lower to use a bulk product. Using det cord while loading, when I've seen det cord used for loading for tracing, I've seen that used in lateral development. So now we switch now to lateral development. At least I think that's what you're asking. And yes, it is a great way to use your perimeter control. There are a variety of products and ways by which you can reduce the charge on your perimeter holes, and tracing will do that, where you're more or less radially initiating using a detonating cord. You have your primary charge, which is your ANFO or your emulsion, and you trace it. And instead of initiating at the back end of the where the detonator is, and the explosive front moves along the length of the blast hole. With a trace product, it moves at an incredible speed. I think 10,000 meters a second. So the entire length of the perimeter hole is initiated instantaneously, and it's more of a radial, so you don't hit your peak particle velocity, which is synonymous with the amount of energy. Hence, you will reduce the amount of impact on the perimeter hole. So yes, tracing holes is an excellent way to reduce the energy on that perimeter hole. The explosive suppliers also have a variety of pre-packaged products that are traced. There are independent contractors, I think Trace It Blasting in Northern Ontario, who does this type of product as well. And there is emulsion machines that have variable density. I think the term is gassing, the amount of gas particles or prills of uncharged can also be, sticking with emulsion, the amount of gas that it's injected into the emulsion will change its density and hence reduce its, if you make it lower density, it'll have less energy and it'll hit less harder on the perimeter. There are different ANFOs that have inserted glass prills instead of the actual ANFO beads, which would be a low density emulsion. So I would suggest talking to your local explosive supplier, talking to their expert, and they know what their products are, and you know what you can get locally. So everywhere might be slightly different, but there is a lot of different ways to change your either tracing or different products for your perimeter control. Let's see. We commented use 9-hole slots with 6-inch reamers for our slots. Okay. I hope I haven't missed anyone's questions here yet, but good question. You will see. There's still more questions about the foam blocks to create a free face. Yes, we could look at that. We talked about that. Okay. And we use massive opening slots. Okay. Okay, there's some people talking about different slots. What do you think of using 4.5-inch diameter and putting casing 3-inch holes? For Lewis. Oh, I think you're talking about, I think Lewis was the one who originally asked about squeezing holes. Yes, I have seen this done before on trenching and pipelining quite often. This is a really common practice where usually river crossings, I've seen it where the holes are exceptionally wet. The river is physically gushing into the hole. So you case the hole with a pipe and you're loading. So the inside diameter of the pipe is different. So you have to drill a bigger outside diameter. You insert the pipe into the hole and you put the product inside the hole. I think you have to also be cognizant of fumes for ventilation purposes. If you're using certain products, they may not meet the fume classes for the underground, and you're going to be creating dangerous, noxious gases. So you have to be cautious about how and what you choose for the casing. So if there is an appropriate product, I haven't used it myself, other than for collaring the holes so that the rocks don't fall into the hole. The casing is just at the collar and it usually doesn't do the full length of the hole. But yes, it might be an idea to help you with the squeezing. It'd be worth a try if you're having exceptional issues with ground squeezing. What is your experience with cable bolting in the hanging wall to avoid dilution? This is from Luigi Sanchez. Yes, cable bolting a hanging wall is a great idea. I really didn't get into it. I'm not a geotechnical engineer, but absolutely. Assuming that the country rock is not your ore, and if you could support that hanging wall and keep it from sloughing, it's the perfect way to go. There is ways to make you can paint a section of cable bolts such that you're doing it out of cycle, so you don't affect the overall production rate. You drive your drift, and there's a way to go in there and try to put in a series of cable bolts as quickly as possible, such that you don't slow down your production. And absolutely, it'll help keep the integrity of your hanging wall for long hole open stoping. It's an excellent idea. David mentioned Brian Boutlier is asking a question. I may have lost the context of this. In caving, you drill 4-inch holes and case with 3-inch. It works very well. Okay, so yeah, Brian's mentioning that he's drilling larger holes and he's casing them, and it works very well with Lewis in caving. He says, Lewis in caving, we also drilled 4-inch and case with 3-inch, which worked very well. Okay, it looks like I might be at the top of the questions. So I'm going to give it a shot here. There's the speak function. I'm going to try to allow Chris Sangster. Chris, I'm going to accept you. It might take a moment, and you'll have to answer some of the questions like test your mic and video, and then quickly. So just follow the prompts, and hopefully it'll allow you in, and we can actually talk face to face here. Hopefully, we'll see how it goes. So far, he hasn't come through. Okay, I may have lost Chris. It's been a few moments. There's a second person asking to speak, which is Nirmal Sharma. I'm going to see if this works. I'm going to try Nirmal. It's the same type of process. Hopefully he comes through. We'll see. It looks like I'm having some technical difficulties getting the people that come through to speak live. I'm sorry about this. Okay, as far as I can tell, oh, there's one more question, Paul. Can you share the PowerPoint with us? Will be a good document for this webinar. I think so. I don't see there being any issues. If you reach out to me directly, Anton, I could probably send it specifically to you if you contact me. And if anyone else does as well, please feel free. I'm on LinkedIn. I think I sent out my contact information to all the invites, so you're welcome to email me, call me. And it looks like I may have come to the end of all the questions. So thank you everyone for sticking around, and feel free to call me anytime. AMC does a series of other things. This is just a small taste of some of the type of work we do. So I hope you all have a safe and happy day, and thank you very much. All right, so all right, Anton says he'll email me. Okay, thank you everyone. I'm going to end the seminar now, and I thank you for your time, and we'll talk hopefully again soon. All right, take care.